This section explains the Rotary Positional Embeddings, RoPE, and code implementation. Let's first look at the RoPE overview. Rotary Positional Embeddings is an advanced positional encoding method introduced to improve transformer models. Unlike absolute positional encodings, like sinusoidal encodings in transformer, RoPE enables relative positional encoding, allowing the model to generalize better to longer sequences. RoPE works by encoding positional information directly into the self-attention mechanism by rotating query and key vectors in multi-head self-attention. This method maintains translation invariant properties and captures the relative positional relationships efficiently. Mathematical formulation of RoPE. RoPE applies two derotation matrices to each pair of dimensions in the embedding space. This is achieved by defining a complex valued representation for each token embedding and then rotating it based on the token's position. Let's break down step by step. 1. Define the token representation. Each token embedding, where D is the embedding dimension, is split into two interleaved parts as follows. Each consecutive pair can be interpreted as a complex number as follows. Now, the rotation operation applies to each complex pair separately. 2. Rotation with position-dependent phase shift. For a given position pi, we rotate each pair of elements using a rotation matrix as follows. Each position p has an associated frequency-based rotation angle as follows. Thus, each embedding pair is rotated as follows. Expanding this, we obtain as follows. This means each embedding vector is rotated by a position-dependent angle, encoding relative positions. Applying RoPE in self-attention. RoPE modifies only the query and key vectors before computing self-attention. 1. Compute Q and K rotation. Rotate half, swaps pairs of dimensions and negates one of them. 2. Compute attention score. After rotation, the attention scores are computed as usual. Since rotation preserves dot product properties, RoPE ensures that the attention scores depend only on the relative positions of tokens, not their absolute positions. Now we implement the RoPE code. Rotate half function. Apply rotary pos m function. Rotary position embedding class. Testing the RoPE.